So area between curves. Let f and g be two functions such that f of x is greater than or equal to g of x for all x in interval AB. Okay, so again, these symbols, for every x that's in the interval AB, the value of f of x is greater than or equal to the value of g of x. Okay, so two functions, one on top of the other. Basically, that's what it means, that f is bigger than g over this interval, is on top, is higher. Okay, so if I am to draw a picture of this, so that would be f, and let's say that would be g, who cares? Okay, so f, g, and this is here interval A, B. The area between the graph of f and the graph of g is, continue here, given by the integral from a to b, and you just minus them. So f of x minus g of x dx. Okay, so I should specify here between the graph of f and the graph of g, so of course, it's always over AB, right?
Sir, what's the word after functions?
Where? Here?
The second line.
Such that.
Okay.
Okay, so this here will give you, this expression will be the area of this region between two functions, which makes sense because we know that the integral from a to b of f of x is the area under f, and the integral from a to b of g of x is the area under g. So if you do area under f minus area under g, you'll get the area between them. Makes sense. All good? Okay, let's try an example. Example. Find the area of the region enclosed by the curves. So let's say y equals x2, and let's say y equals x. Okay, so the first thing I'm going to do is I'm going to draw my two curves and represent my region. Okay, so y equals x2. Of course, this is a parabola. And y equals x, it's the straight line, right? The bisector of the first quadrant. So this is the area that I'm looking for. Okay, so this should be clear for all of you. Anybody have a question on this? Okay. So I need to find this point here, because when I'm going to do the integral, I'll do the top function minus the bottom function. I will have to know what are my bounds. Okay, so I need to find what that is. This obviously is 0, but I see it on the graph, but let's do it algebraically. Okay, so let's find the intersection points. How do we find the intersection point between these two curves?
Make system of equations.
You solve a system of equations, very good. So the system is y equals x and y equals x2. You could use whichever method you want. So in this case, it's set up in a way that a comparison would be great. So x2 is equal to x, which means that x2 minus x is 0. So x times x minus 1 is 0, and therefore x is 0 or x is 1. Is this clear?
So this is how we find A and B.
Exactly. Exactly. Okay. So I need to find the y as well. Let's find the y for each one. So if x is 0, so I could plug x is 0 in any of these two equations. I get x is 0, then y is 0. And then if x is 1, then of course y is 1 as well. And so I found my two intersection points, which is 1, 1, and this is 0, 0. Any questions so far? Okay, so I'm ready to set up my integral now. So the area is the integral. So x goes from 0 until 1 of the top function, which is, what is the top function? It's x minus the bottom function, which is x2 dx. Okay, I'm gonna write this here. This is the top function, and this is the bottom function. Any questions? Okay, there's just one little difficulty here, is that how do you know which function is on top, which one is on the bottom? Okay, so here it's pretty obvious because I look at the graph, and these are two very easy functions to draw. But if I give you something a bit more complicated, then you won't know which is on top, which is on bottom. What would you do? What do you suggest we do to determine which is at top, which is bottom?
If it's
plug in.
like
plug in any point in between A and B
Yeah.
for each function and see which one gives a bigger Y.
Exactly. So what you would do is you would take a test value between 0 and 1, in this case, let's say 1/2, and you plug in 1/2 into y equals x, and you plug in 1/2 into y equals x2, and you will get 1/2 here, and you'll get 1/4 here. And so 1/2 is bigger than a quarter, so you know that this function is above. And okay, so in this case, it's easy to draw it precisely, but sometimes functions you're going to see just, I don't care what it looks like. Okay? Just make sure that you know when they intersect and which one's on top, which one's on bottom, so that you can find the integral. Any questions? Okay, so at this point, this is a very, very easy integral to evaluate, as you see. So this is just x squared over 2 minus x cubed over 3. All this evaluated from 0 to 1. That gives me 1/2 minus 1/3, and that's 1/6. This 1/6 is the exact area, so 1/6 units squared, whatever the unit is the area of this region. Let's try one. So find the area of the region enclosed by the curves. Let's say y is equal to x cubed and y is equal to 2x 4x. Okay, y equals to 4x. Okay. I think that's a good one. Okay, try it out. What does this look like? So y equals x cubed is a function like this. Y equals 4x is a function like this. Okay, so I'm looking for these two regions, the area of these two regions. This is y equals 4x, and the curvy one is y equals x cubed. Any questions?
So in a test or exam, do we need to draw this graph?
And if you can, you should.
Which not compulsory, right? Like we can draw it like while calculating on some sheet, but is it compulsory like for marks?
Not compulsory,
Okay.
but it is very useful, especially when we're going to do volumes. We're going to take a region like this and we're going to rotate it around an axis and find the volume. So you have to, it's very important to visualize.
Okay.
So I mean, I'm not going to give you very hard functions to draw. Okay, it's probably going to be parabolas and straight lines and maximum a cubic like this. Okay, so not too complicated. So let's find the intersection points. Again, so I solve the system y equals 4x and y equals to x cubed. I do a comparison. So x3 equals 4x, x3 minus 4x is equal to 0. X times x squared minus 4 is 0. X times x minus 2 times x plus 2 equals 0. And so either x is 0, x is 2, or x is minus 2. Okay, if x is 0, then y is 4 times 0, that's 0. If x is 2, y is 8. And if x is negative 2, y is negative 8. So I found my 3 intersection points, which are 2, 8, 0, 0, and negative 2, negative 8. Do you have any questions?
Sir, how do you find the intersection points?
I solved the system of equations here.
What did you do for the system? Like which way did you do it?
Which way did I do it? I compared. I did x3 equals to 4x.
Oh, okay.
Right? The y's are equal, so the x3 and the 4x has to be equal as well.
Oh yeah. Oh, I didn't see that. My bad.
What I did was I divided the 0 by x. So I took out the x from both sides. And then I did x squared equals to 4. And then I did x equals negative 2 and x equals 2. But I didn't get x equals 0.
You know why? Because you divided by x. Who says you're allowed to divide by x? You could only divide by x if x is not 0. You're not allowed to do. Here at this point, you cannot divide by x.
Okay.
Yeah, because you don't know if x is 0 or not. And by the way, it could be 0.
Oh, because if it's 0, then it won't work. Okay.
Exactly. If it's 0, you won't be able to divide by x. Okay. So always factor and do each term could be 0.
Okay.
Okay, good. So now we're going to set up our integral. So the area will be, so I have to do 2 regions now. There's 2 regions. From x equals negative 2 until 0. The top minus the bottom. The top in this case is x cubed minus the bottom, which is 4x. Plus, from 0 to 2. Now from 0 to 2, the top, right? This is 2. This is minus 2. From 0 to 2, the top is 4x and the bottom is x cubed. That's it. Once this is set up, the rest is easy. Okay? So usually when you set up your integral, you get most of the points. The rest is just calculation, and most of the time they're going to be very easy integrals to evaluate. Okay, let's do it. So this is x4 over 4 minus 2x2 evaluated from negative 2 to 0 plus 2x2 minus x4 over 4 evaluated from 0 to 2. So I get 16 over 4. This is 4 minus 8. Did I make a mistake? Oh, that's fine. So I have 0 minus, and if I plug in 2 minus 2 here, I get 4 minus 8 is negative 4. Perfect. Plus, and if I plug in 2 here, I will get 8 minus 4, which is 4, minus 0. Yeah, that's what I get. And so I get minus 4 plus 4, I get 8. This is my area. Another example. Find the area of the region enclosed by the curves. So let's say y equals 5x minus x2 and the line y equals x. So this is a parabola and this is a straight line. This parabola is open downwards because there's a negative in front of the x2. Okay, so let's just find right away, instead of drawing the exact, we could draw the exact parabola, but I prefer finding the intersection points, knowing that this is a parabola and this is a straight line. Okay, so let's start with the intersection points here. So x, y equals x, and y equals 5x minus x2. If I solve this, I get x is equal to 5x minus x2, x2 minus 4x equals 0, x times x minus 4 equals 0. So x is equal to 0 or x equals 4. Okay, so basic algebra here. If x is 0, since y equals x, then y is 0. And if x is 4, then y is 4 as well. Okay, so I could draw a rough sketch now. Doesn't need to be exact, but one thing that's for sure is that 1, 2, 3, 4, 1, 2, 3, 4. At 4, 4 they meet. Y equals 4 is right here. Y equals x equals here. And the other one is an upside down parabola. Something like this. This is the region that I want. Intersection points 0, 0, 4, 4. Okay, and it's pretty clear that the top function is the parabola and the lower function is the y equals x. So let's set up the integral. X goes from 0 to 4. And top function, 5x minus x2 minus bottom function. Okay, let's do this. So this is 4x, so this will be 2x2 minus x3 over 3. Evaluated from 0 to 4. So what is that? That's 16, 32 minus 64 over 3. I don't know what that is. 96 minus 64 is 32. So I get 32 over 3, I think. Okay, if I didn't make any calculation mistake. Here's my calculator. Yeah, 32 over 3 is right.
Is it 2.5x squared?
Excuse me?
Is it 2.5x squared instead of 2x squared? When you derive the 5x. I mean, yeah. No, integrate the 5x.
No, because I first did 5x minus x is 4x.
Oh,